With 1 second left on the clock, a basketball player shoots a desperation shot. The ball leaves her hands exactly 0.9 meters below the rim at an angle of 35 degrees above horizontal, and the ball goes in just as the buzzer sounds. So this is supposed to be 1 second because there is 1 second left on the clock. We're starting at time 0, we're starting at position 0, and the net is 0.9 meters above where the ball leaves the hand, so our 2y is 0.9. And if you do a free body diagram for the ball, you got the force of gravity acting on the ball, and so we have the acceleration in the y direction is negative 9.8. And then from our vector diagram here, well, we have the velocity times delta t. The velocity is at an angle of 35 degrees above horizontal, and we have the acceleration vector going straight down. So delta rx is equal to the cosine component of v1 times delta t. v1 times delta t sine of 35 degrees, that goes from here to here, so that's equal to 1/2 of 9.8, which is 4.9 times delta t squared plus 0.9. We can put in delta t is equal to 1 second and solve for v1, and we get v1 is equal to 10.11. That is the magnitude of v1. You could write that like this. And the x component, since v1's at an angle of 35 degrees, the x component is 10.11 times cosine of 35 degrees, and the y component is 10.11 times sine of 35 degrees. We can put these values into our table, so this is 8.28 meters per second, and this is 5.80 meters per second. The acceleration in the x direction is equal to 0, so v2x is 8.28 meters per second. We have to find r2x. Well, if r1x is equal to 0, r2x is equal to delta rx, we can use this equation. And now that we found v1, we can put that in here, and we get 8.28 for r2x. And finally, we have to find v2y, which we can use our velocity kinematic equation for. So v2y is equal to v1y plus a12y times delta t. Plug in our numbers, and we get for that -4. So we can take that, put it in our table, and we are done.